Hello there, and then welcome to Hub Beyond Numbers, where we learn maths the easy way. In this video, we are looking at application of the Pythagoras Theorem. In our previous video, we looked at what the Pythagoras Theorem is and then how to apply it toward triangles, that is right angle triangles. Now, in this one, we're actually looking at some word problems that would call us or that would need us to use the Pythagoras Theorem. So without much ado, let's quickly go into it. So this question here says, as you can see, it says a ladder leans against a wall. The end of the ladder touches the wall 12 meters from the ground. The foot of the ladder is 9 meters away from the foot of the wall. And the question is, what is the length of the ladder? What is the length of the ladder? So how do we go about this? So to be able to answer this question, you would have to be able to rewrite this or get the graphical representation of the question. So let's quickly look into how we are going to do that. You can take a close look at the question, because if I shift, I don't think you might see the whole question. All right. So you can take a screenshot as well. So with that said, let's quickly go into how we can represent it. So the first part of the question says what? The ladder is leaning against a wall. So that should mean that there is a wall. There's actually a wall. All right. So if there is a wall, then I'm going to draw something that will represent my wall. And you know, walls are mostly vertical, right? So I'm just going to draw a vertical wall over here. So this here is going to be my vertical wall. And I'm being told that the end of the ladder touches 12 meters from the ground. 12 meters from the ground. All right. It actually says it touches what? The wall 12 meters from the ground. So if this is my ground over here, this is the ground. All right. So let's say if this here is my ground, then 12 meters from the ground, the ladder touches the wall. 12 meters from the ground, the ladder touches the wall. So something like this. So if this is where I want to put it, this should be my 12 meters from the ground. The ladder leans like this. This is how the ladder leans. And it is what? 12 meters from the ground. So with this now, the second part is the foot of the ladder. So if this is the foot of the ladder, it is what? 9 meters away from the foot of the wall. So you put our 9 meters over here. Very simple. And with this, you can apply your Pythagoras theorem. All you need to do is what? To indicate that this angle here is 90 degrees and you are good to go. So this here is our wall, this is the ladder, and this is the ground. So all we want to do is what? Calculate the length of the ladder. Very, very straightforward. Right? So how then do we calculate the length of the ladder? Using the Pythagoras theorem we learned in our previous video. So we say using the Pythagoras theorem. So using the Pythagoras theorem, we know that what? If we want the length of the ladder to be L, then we know that the length of the ladder squared, which is now the hypotenuse. The hypotenuse is always the slanted side, which is the longest. So the length of the hypotenuse squared is equal to the sum of the square of the other two sides. And that is 12 squared plus your 9 squared. It's all about evaluating and then simplification. So L squared is equal to 12 squared gives us 144. And then 9 squared on the other hand gives us an 81. And our L squared is equal to, if you have to evaluate, we have 225. So our L squared is equal to what number squared gives us 225? That is 15 squared, you see. So since they all have a square, we can just say L is equal to what? 15. The unit is meters, right? So that is it. If you want to find square root to write from this point, you can say L squared is equal to actually 225. So finding the square root of both sides. 2 here takes care of the square root, and then we'll be left with what? An L. And we know the square root of 225 to be what? 15. Hence the length of the ladder is what? 15 meters. Straightforward and very simple, right? So you can always rewind and then look at how it was solved. Now let's look at the next question over here. It says in the diagram, MN equals 13 centimeters. This is MN, 13 centimeters, and as indicated over there. MP is what? 15 centimeters. And then MS is 12 centimeters. All has been indicated. The line MS is perpendicular to NP. So all that they are trying to tell us with that statement is that this here is a right angle. All right. So let me just indicate that it is a right angle. So if it is a right angle, then it simply means we can actually apply the Pythagoras theorem. So you have to calculate the length of NP. Now you have to pay a critical look at this question over here. You have to calculate the length NP. To solve for NP, we first need the length of what? NS. You see? So after the length of NS, then we can add or solve for the length of SP as well. And then from there, we can do what? Add them up to give us our NP. So let's first of all solve for NS. So I'm going to draw this triangle again here, then we solve for the NS. So just as we can see from the diagram, I have drawn this right angle triangle here, and I want to solve for NS. All right, I want to solve for NS. So how do we go about it? We want to use the Pythagoras theorem. So from this triangle, that is triangle MNS, you see, so from this triangle, we can say that, okay, the magnitude using the Pythagoras theorem, we are still applying that here. So the magnitude of the hypotenuse, which is MN squared, is equal to the sum of the squares of the other sides. That is MS squared plus NS squared. I think there's a side I didn't write, that is 12 centimeters. So this here is 12 centimeters. All right. So this is actually what we want. So let's do our substitution. We know MN to be what? 12? No, it's 13. That is MN. So 13 squared is equal to MS. MS is 12. So 12 squared. Then plus the length of NS, which we do not know. So we are now trying to make this here the subject. And how do you do that? You can quickly move this to the other side, so that you are going to have a 13 squared minus 12 squared is equal to NS all squared. And we know 13 squared gives us a what? A 169 minus 12 squared, which is 144, is equal to the length of NS squared. 169 minus 144 gives us a 25. So it means NS squared is equal to what? 25. And we know the number whose square is 25. You see, so you can find the square root and simply say, oh, then NS is actually 5. So NS, that is the length of NS is what? 5 centimeters, because it's 5 squared, that gives us 25. With that done, we now have to look for the length of SP. The length of SP. So we would draw that triangle, the part of that triangle as well, and then that is going to help us look forward the SP. So I'm coming to draw that right over here so that we can make inference. So this is what we have over here, just like the previous one. We can say the length using the Pythagoras theorem. We can say that the hypotenuse, which in this case is MP. So the length of the hypotenuse, that is MP all squared, is equal to the sum of the squares of the other side, which in this case is what? MS plus SP. All right, so let's do a substitution. MP gives us a 15, and then MP gives us a 12, not forgetting their squares, plus SP all squared. we would have to make SP the subject. So we have 15 squared minus 12 squared, giving us SP all squared. 15 squared gives us a 225. We have 225 minus 12 squared, which gives us a 144, is equal to the length of SP squared. So 225 minus 144 gives us an 81. So 81 is equal to SP all squared. What number squared gives us 81? That is 9. So SP is equal to what? 9. But the question was that we were to find the length of NP. The length of NP. And we said the length of NP is just what? The sum of NS and then what? SP. So we come back here and then we say that the length that they asked us to look for, that is the NP, is actually equal to SP, that is NS rather. So NS plus SP. All right. And we have already solved for all of this. So NP in our question is then going to be equal to a 5 centimeters plus 9 centimeters. So our NP is equal to what? 14 centimeters. As simple as that. So this is how we apply what? The Pythagoras theorem. There are so many applications, but because of time, I'm going to leave this here and then we can continue another time. I'll write out some questions you can try on your own. If this is your first time on this channel, this is How Beyond Numbers. And if it was helpful to you, you can always choose to subscribe so that anytime I release any new videos, you can always be notified. So these are some questions you can always try your hands on and then to test your understanding. The length of a side of an equilateral triangle is 12 centimeters. You have to find the height, the area, the perimeter, and the perimeter of the triangle. Then the second one says, a ladder leans against a vertical wall, of height 13 meters. If the foot of the ladder is 6 meters away from the wall, you have to calculate the length of the ladder. All the best and then stay blessed. See you in our next video.